Now, move on to the second type of question for AP Physics 1. Second type of question is the paragraph argument short answer question. And I will use the second sample question on the same booklet, AP Physics 1 course and exam description. And if you still don't have that lecture, booklet, then you can download it from the link below this video. Let's remind the strategy for this paragraph argument to short answer problem. Strategy 1 and 2, similar to the quantitative qualitative transition problem, we need to read all entire question at first, quickly, and collect the core word and important information from there. Strategy 5, especially for the paragraph argument, is the most important thing, and your first sentence is everything. So if the question asks, do you agree or do you disagree? Then your answer should start with, yes, I agree, or no, I don't agree. And if the question asks, is A is greater than or the faster than B? Then your answer should start with, yes, A is greater or faster than B, or no, A is not greater or less than B, or A is slower than B. So you have to make a direct answer about the question, and this is for the first sentence. Sometimes the question may ask just the explanation. Then your first sentence should be a core concept, the explanation what the core concept of that the physical situation given. It's very easy. Sounds like it's easy and straightforward. No, but it's actually difficult, because in our normal conversation, we usually just giving less important things first and just giving final answer at last, like as a just conclusion. Okay, but for scientific writing, you should giving the most important thing at first, and then rest of them just supplementary for that. Especially for this kind of the exam, the writing exam, then you have to giving every your idea on the first sentence. So help the graders to understand your thinking by reading just the first sentence only. Okay, that's the key thing. And strategy 6, equation, graphs, drawing are your weapon. Okay, if you're using the equation and graphs or the drawing, it's very easy to explain a physical situation without any unnecessary additional explanation or description of that. So use it to make your writings more neat and coherent. Now we will just apply this strategy on the sample question. Okay, this is the sample question on that booklet that I mentioned before on the page 219. So find out. And first thing you need to do is you need to read on entire question thoroughly and quickly. Okay, so just pause the video right now and just read the whole question thoroughly and just come back. Okay, so I believe you guys already read it, and this is just the main explanation for this question, and try to find out what is the core concept and important information on there. If I were you, I choose unstretched length L1 is hung very vertically when the block hangs at rest, then pulled downward and held in place. I choose these things as a core words. Why? What are they? What kind of hint did you catch from there? They all be stationary, right? So all three cases, net force is just equal to 0. That's the most important concept that we catch. So whatever that is, in each three cases, they are all net force equals 0. So from now on, unless the question actually giving additional information to change the situation, this net force equals 0 is our key to understand this and explain about the situation. Yes, A. What did you catch? I choose draw and label the forces, and a distinct arrow starts on and pointing away from the dot. Okay, so this one is actually, we recognize, oh, this question asks drawing the free body diagram on this dot. Yes, we need to draw the free body diagram, but don't forget labeling. Okay, the question asks draw and label the forces. So you have to label. A lot of students actually forget about the labeling after drawing the proper free body diagram, so they actually got the partial mark off. Okay, it's not good. And the distinct arrow starts on the pointing away from the dot. Okay, sometimes some of the students actually giving, if you have a material, an object over here, if somebody push the force from left to right, they actually drawing the force like that. But this sentence specifically say do not draw the arrow like this. The arrow should start from the dot and pointing away from it. Okay, although maybe the force is pushed this way, but you have to draw the force from the object and pointing away from it. Okay, so that's the one of the tip for drawing the free body diagram. For this case, we have mg, okay, and we have applied force from your hands, okay, and you have spring force. Okay, index is up to you. You better just explain what is Fs and F applied if you have enough time for that. So F is a spring force on it, and this applied force is just pulling force by hand. Okay, the key thing is that when you draw the free body diagram, if you have a question asking drawing the free body diagram, the length of arrow and the direction of arrow. Okay, of course you guys practice a lot for the finding the correct direction of the arrows. For here, the sum of the lengths of these two arrows should be similar to the length of this one, because this one is the net force equals 0 case, right? So when you draw the graph, the free body diagram, think about the actual, well, we don't know the exact value, okay? So, but the relatively, the reasonable lengths, you should use the reasonable lengths to draw the arrow for the force on the free body diagram. That's the key thing and the answer for number A. We are on question B. This is the part for the paragraph argument questions. So, what are the core information from here? Did you find it? I found the student release the block. Yes, release the block. Okay. Previously, all three cases was the net force equals 0. But because the student release the block, change it. So net force is not equal 0 anymore. You have to catch it. And the spring length is still longer than L2. So that means the block is actually still lower than this equilibrium position. So it's actually moving up with upward acceleration. Okay, net force should be toward upward. And this is the most important part because this is the question. Okay, you need to write down why the total mechanical energy is the increasing, decreasing, or the constant for each of the systems listed below. Okay, system 1, system 2, system 3 in that question. Okay, and use E1, E2, and E3 to denote the total mechanical energy of the system 1, 2, and 3 respectively. This is also important because when you write down the paragraph, you have to use given notation. Okay, so you should use a given notation. So this is also important information. But this one, yes, we need to answer about why. We need to answer about the why. So this is explanation. Okay, so when you explain this one, we need to explain three things. Why the total mechanical energy is increasing or decreasing or constant for each system. So we have three systems. So you will have at least three sentences to explain those kind of things. Okay, and when you read this one, so you have to recognize, oh, I have to explain about this thing. Second thing, what is about? This is about the total mechanical energy, conservation of an energy. Okay. Whenever, I'm pretty sure you will have a question asking these kind of things, not only for the energy, but I'm talking about the law of conservation. Okay, so law of conservation, like energy or momentum or angular momentum, these kind of things. Okay, these, whenever you deal with this conservation, law of conservation, the most of important thing is what are in your system. Okay, what object is actually included in your system, and which object are excluded from your system. That's the most important part. Depending on that, the object in your system, the energy should be considered in different way. Okay, so linking the system and the conservation law is very important. Okay, if you actually have no idea what I'm talking about, you have to go over and you have to review then about the system and the conservation laws, especially for the energy and the linear momentum and angular momentum. Okay, so for this case, I will briefly explain about the energy conservation. Now we have the block, spring, and the earth. Kinetic energy is belong to a moving object. So whatever the object is moving, the kinetic energy is on that object. So if you have the object in your system, yes, you have a kinetic energy, and you have to consider the kinetic energy one of the part of your total mechanical energy. Elastic potential energy belong to compressed or stretched spring. It has the elastic potential energy on the spring. Okay, so if you consider the spring as a part of your system, yes, you should consider elastic potential energy. These two are easy, kind of. The third one is important, and a lot of students is actually confused about this one. Gravitational potential energy is coming from the work done by gravitational interaction, which is a gravitational force between two objects. So this potential energy, this gravitational potential energy, is belong to both objects. So if we are talking about the gravitational potential energy due to the gravity force of the Earth, then you should have Earth in our system. So if you consider the Earth is not in your system, then we don't have gravitational force in our system. Okay, so we have to consider the gravitational potential energy as just a part of the total mechanical energy if you consider the Earth is also one part of our system. Keep in mind of that, and that is a key of this question as well. So if you understand what I explained in the previous slide, you can find out the answer for this question, and I will show some of the example of the sentence that I made for this paragraph argument. So for explanation for the E1 is the total mechanical energy of the system 1 is increasing because the system 1 has the block only. So we have to consider the kinetic energy of the block only. Where the kinetic energy is coming from doesn't matter. It's coming from outside. In our system, we only focus on the block only. So we have a kinetic energy only. While the block becomes faster, speeding up, then kinetic energy just increase. So that's this E1. So E1 is increasing because it includes the kinetic energy of the block only. The kinetic energy increase as the block is accelerating upward. Move on for the second system. For second system, we can actually explain into two different ways. The first one, E2 decreasing. Why? Because the force of gravity only can generate work on the system 2, and it is negative work. Do you understand that? We have the block and the spring inside our system. Okay, so gravitational force is actually external force on this system. So we need to think about what happened by this force, work done by external force on the system. And while the object is going up, gravitational force is downward. So when you consider FD cosine theta is opposite direction, will have a negative work on the system. Okay, so we have an external force generating negative work on this system while the system goes up. The total energy must be decreased because only external force actually generating the negative work on it. Okay, so you can explain that way. Or the other way, of course, we will explain about the E3 later, but E3 is actually including everything: block, spring, and the Earth as well. So if you including this whole system, this system is isolated system. Once the system is isolated system, then we can talk about the law of conservation of energy. So since energy must be conserved in an isolated system, so E3 should be consistent. And E3 should including kinetic energy of the block, potential energy, spring potential energy, elastic potential energy of the spring, and gravitational potential energy as well. So if I just write down here, E3 is equal to kinetic energy of the block and potential and elastic potential energy of the spring and gravitational potential energy as well. And these two are total mechanical energy of the E2, system 2. Because in the system 2 we have block and spring only. So if we write down E2, isolate E2 from there, E2 is E3 minus gravitational potential energy, and gravitational potential energy mgh. So while the object is going up, h is increasing, this gravitational potential energy increase. So without changing this E3, because this is total mechanical energy of the isolated system, with increasing this mgh, this part should decrease because we have to subtract more from constant. So that make E2 is decreasing. Okay, so you can explain with work done by the external force, or you can explain with E3 in this concept. The last one is E3. I already explained on the previous slide. Yes, so E3 is constant because system 3 is closed or isolated. E3 is constant because there is no external force on the system, because this is isolated system and there is no external force from there. So that is another way to explain why E3 must be constant. This is the case that we can consider the law of conservation of energy, because the system is closed and isolated. So if I wrap up everything, okay, I need to adding these all three sentences to explain about the E1, E2, E3, but as my first sentence, I will write down this one first. E1 is decreasing, increasing, E2 is decreasing, and E3 is constant for system 1, 2, and 3 respectively. I will clearly show this one first, and then I will explain why E1, E2, E3 like the previous slide. Okay, so the grader will read this first sentence and they'll recognize, oh, this student already know the correct answer. Okay, so then they can actually easily go over this one and to find out that, oh, this part is supporting this part is supporting this, and this part for that. So you can get a full mark for that. Okay, so that's the reason why we have to show the kind of the short conclusion or the most important thing on the first sentence. Okay, thank you for watching my video lecture, and I hope this was helpful for you guys. If you have any question about this video lecture and anything about the AP Physics exam, you can email me. I will do my best to answer every questions to you. And if you actually prepare the AP Physics 2 as well, then there will be 2 more additional lecture follow this one, and to explain the quantitative qualitative transition problem and the paragraph argument problem set for AP Physics 2 problems. So you better watch them too. Okay, thanks again and good luck.